Hi, good morning all. It's me Muhuddin. Today we are going to discussing anomalous properties of nitrogen. Firstly, some basic information about nitrogen. It's discovered by Daniel Rutherford in 1772 and the origin of name. The name is derived from the Greek nitron and gens meaning nitriforming. Some atomic properties, electronegativity 3.04 in Pauling scale and ionization energies. Here first ionization energy is 1402.3 kilojoule per mole. Oxidation states 5, 4, 3, 2, 1, minus 1, minus 2, minus 3. And van der Waals radius is 155 picometer. Now, why nitrogen differs from the rest of the members of the groups? 50. Here is the answer. Due to its small size, high electronegativity, high ionization enthalpy, non-availability of d orbitals in the valence shell. Now, we are going to discussing about the some anomalous properties of nitrogen, rest of the group members. Here, nitrogen is gas while other members are solid. Nitrogen has unique ability to form p-pi multiple bond with itself and with other elements having small size and high electronegativity. For example, carbon, oxygen. Heavier elements of this group do not form p-pi bonds as their atomic orbitals are so large and diffuse that they cannot have effective overlapping. That's now p-pi bonds are bonds that are formed by the overlapping of p orbital perpendicular to the internuclear axis. For example, here p-pi bonding examples NO in CN. Here in NO there are two double bonds and CN triple bonds. Here a small picture that is represent the p-pi multiple bonds and it will be a perpendicular to internuclear axis. Next point, nitrogen exists as a diatomic molecule, that is N2 with a triple bond, that N triple bond between two atoms, and it is gas at ordinary temperature. Since nitrogen is able to form p-pi multiple bonds, here is the given these two blue spheres is represent to the nitrogen and the bonds are given here triple bonds. Okay, then phosphorus, arsenic, and antimony form single bonds. Okay, that is phosphorus and antimony P single bond P, S single bond S, and Sp single bond S. Whereas bismuth form metallic bond in elemental state. As a result, they exist as a polyatomic molecule, അതായത് P4, S4 and Sb4, and are solid at room temperature. Since the bond enthalpy of N triple bond N is very high, that is 941.4 kilojoule per mole, nitrogen is very stable and relatively less reactive than other group 15 elements in the elemental state. Next, unlike the heavier elements of group 15, nitrogen does not have d orbitals in its valence shell. As a result, nitrogen cannot form d-pi-p-pi bond. Nitrogen cannot form d-pi-d-pi. Sorry, I am repeating, nitrogen cannot form d-pi-p-pi bond, while the heavier elements can. For example, R3PO, here double bond PO, or R3P double bond CH3. Here R represent as an alkyl group. You know what I mean, alkyl group. Further, phosphorus and arsenic can form d-pi bond too with transition metals when molecules like PCH2H CH2H CH sorry PC2H5 thrice, comma arsenic C6H5 thrice, etc. act as the ligands. Now, weak catenation tendency. Tendency for catenation is less in nitrogen as compared to the other metals of the group. And single bond N is weaker than those of the other elements. This is due to the high inter-electronic repulsions of non-bonding electrons owing to the small n bond n length. Then next, nitrogen shows a large number of oxidation states in its compounds. The heavier elements of group do not show such a variety of oxidation state. Here I have given a table which represent the oxidation states of nitrogen. Look at this. Ammonia. The formula is NH3 and its oxidation states of nitrogen in ammonia is minus C. Then hydrogen is formula N2H4 is and then its oxidation state is minus 2 and hydrate N2H2 minus 1 and dinitrogen gas N2 is oxidation state is 0. Then nitrous oxide N2O plus 1 and nitric oxide NO plus 2 and dinitrogen trioxide N2O3 plus 3, nitrogen dioxide NO2 plus 4, nitrogen pentoxide N2O5. The oxidation rate of nitrogen is plus 5. Then the hydrates of nitrogen, namely NH3, is thermally stable and non-poisonous. NH3 is thermally stable and non-poisonous. Okay, the hydrates of heavier elements of group 15 are less stable and poisonous. NH3 is stable and non-poisonous, but other heavier groups elements are less stable and poisonous. Okay, let's move to next points. The only trihydrate, that is MH3 of group 15 which has intermolecular hydrogen bonding is NH3. That is only in NH3 as a intermolecular hydrogen bonding. As a result, NH3 has a boiling point higher than those of the pH3 and AX3. The boiling point of NH3 is minus 33.4 degrees Celsius, but in pH3 minus 88.5 degrees Celsius and AX3 minus 62.5 degrees Celsius. Okay. Then among the trihalides of nitrogen, that is an X-ray. X means X is the halides. Okay. Only NF3 is known to be stable. That is, note the point. Only NF3 is known to be stable, and the others NCl3 and Br3 and I3, that are the halogens, you know it, are highly unstable and very reactive. Only NF3 is stable. Others like NCl3 and Br3 and Ni3 are highly unstable and very reactive. So the trihalides of heavier elements of group 15s are stable and less reactive, but the other elements group 15 stables and less reactives. Then unlike the heavier elements of group 50, nitrogen do not show pentavalency. Note the point, nitrogen do not show pentavalency. The main point, it is the main point, for nitrogen does not show pentavalency. For example, nitrogen does not show form a pentahalide like NCl5. We can accept a question here. There is NCl5, there is no NCl5, but there is in PCl5. This give a reason. Okay, so nitrogen does not form a penta halide like NCl5 because nitrogen does not have d orbitals in its valence shell. That is n is equal to 2. There is no d orbitals in nitrogen. We know it, and it is maximum covalency is restricted to 4. അതുകൊണ്ട് തന്നെ so there is no d orbital, so its maximum covalence is restricted to 4 since only for one, that is the reason is given in the bracket 1 2x and 3 2p, that is the 4 2 2 plus 2 plus 2 is equal to 4, that is 4, therefore covalency is 4. So orbitals are available for hybridization, that means for the hybridization the covalency is, the orbitals is available for only 4, there is no 5. It is due to the absence of the orbitals. But in the case of the heavier elements of group 15 can form pentahalides like PCl5, SbF5, etc. because their atom possess valence shell d orbitals. In valence shell, they possess d orbitals, which can take part in hybridization and bonding. This we almost discussed the anomalous properties of the nitrogen. I hope you will understand of all things that we discussed here. Thank you so much for listening my presentation, watching my presentation and listening my voices. Thank you very much.